Good morning to everyone. Myself is Shefyaz. I am from the Electrical and Electronics Department in Srinivasa Ramanujan Institute of Technology at Anantapur. Today we are discussing about square wave generators in the subject of analog circuits. Introduction to square wave generators. Square wave generators produce a waveform that alternates between two levels at a fixed frequency. They are commonly used in various electronic applications, including signal processing and clock pulses. Understanding their operation and application is essential for engineers and hobbyists alike. Definition of square wave. A square wave is a non-sinusoidal waveform that has a distinct rectangular shape. It alternates between a high and a low state with equal duration, resulting in a 50% duty cycle. These characteristics makes it useful for digital circuits and timing applications. Types of square wave generators. These are primarily two types of square wave generators: astable and monostable multivibrators. Astable multivibrators continuously oscillate, producing a square wave output without an external triggering. Monostable multivibrator generator generate a single pulse in response to an input trigger, creating a square wave pulse. Astable multivibrator circuit. The astable multivibrator consists of two transistors, resistors, and capacitors configured to create a feedback loop. It generates a continuous square wave output with adjustable frequency and duty cycle. Commonly, the 555 timer IC is used to build an astable multivibrator circuit. Monostable multivibrator circuit. The monostable multivibrator circuit produces a single output pulse when triggered by an external signal. The duration of the pulse can be adjusted by changing the resistor and capacitor values in the circuit. This type of generator is usually useful for creating precise timing applications. Frequency and duty cycle. The frequency of a square wave is determined by the time period of the high and low states. Duty cycle refers to the proportion of time the signal is high versus low, expressed as a percentage. A 50% duty cycle means the square wave is high for half the period and low for the other half. Applications in electronics. Square wave generators are widely used in digital electronic for clockwise and timings. They are also utilized in pulse width modulation for motor control and signal modulation. Other applications include testing circuits and generating audio signals in synthesizers. Advantages of square wave generator. Square wave generators produce a simple and cost effective way to generate signals. They produce a clear and distinct waveform making them ideal for triggering devices. Their ability to easily adjust frequency and duty cycle adds to their versatility in applications. Disadvantages of square waves. Square waves contains a harmonic that can introduce noise in analog circuits. The sharp transitions in the waveform can lead to electromagnetic interference. They may not be suitable for applications requiring smooth sinusoidal waveforms. Waveform characteristics. A square wave has a fast rise and fall time which contributes to its square shape. The waveform oscillates between two voltages, creating a distinct on or off single patterns. Harmonics produced by the square wave can be analyzed using Fourier series. Generating square wave with software. Square waves can also be generated using software-based signal generators on computer. Digital audio work substations and programming languages like Python can create square wave signals. These methods allow for precise control over frequency, amplitude, and other parameters. Square wave generators in oscilloscopes. Oscilloscopes often use square wave generators to calibrate and test their performances. A square wave input allows for easily visualization of signal characteristics on the oscilloscope. This testing method ensures accuracy in measuring waveforms in various electronic devices. Square wave versus sine wave. Unlike square wave, sine waves has a smooth continuous oscillations, lacking sharp transitions. Sine waves are often preferred in audio applications due to their natural sound characteristics. The choice between square and sine wave depends on the specific requirements of the applications. Future trends in square wave generators. Advancement in technology may lead to more efficient and compact square wave generator designs. Integration with microcontrollers and programmable devices will enhance functionality and versatility. Future developments may also focus on minimizing harmonic distortion and improving signal quality. Conclusion. Signal wave generators play a crucial role in modern electronics and signal processing. Their simplicity and effectiveness make them a staple in both educational and industrial settings. Understanding their principles and applications is essential for anyone working in electronics. Feel free to modify any part of this presentation to suit your needs. Thank you for giving this great opportunity to me.